Okay, so this is section number 3 of chapter 3. We will be discussing about linear functions. Well, linear functions or linear equations. What's going on? Just happened. Linear functions and linear equations are the same things. They're the same concept. So if you already knew a little bit about linear functions, linear equations, which are in the format of standard form. Standard form would be when you have the equation in the format ax plus by equals c. That's the standard form. The point slope form, the point slope form is when the equation is given to you, they give you the description of the equation, but they don't really give you the actual equation. For the standard form, the equation is given to you, or they can ask you to write the equation in standard form. But point slope form is typically when they give you a point of the linear equation, say they give you x1, y1, and then they give you the slope of the line. Let's say the slope is m, and then they can ask you to find the equation of the line in point slope form, which would be y minus y1 equals the slope m times x minus x1. Well, obviously the x1, y1 are the two values that are the x and the y components of the point, and the m is the slope of the line. So that's point slope form. And then there is also the slope intercept form. The slope intercept form of the line, that's when they give you the slope of the line, let's say m, and they give you the y-intercept of the line. Say 0b, for example, the y-intercept of the line. The y-intercept would be a point that is, that's a point where the line intersects the y-axis. So it's always going to be 0 because this point will be located on the y-axis at y equals b. So then your equation will be given as y equals m is the slope, x plus b is the y component of the slope intercept. I mean, of the y-intercept of the line. So these are the 3 different formats the line can be represented on. And then finally, since we are talking linear functions, so we can write the slope intercept form in function notation by replacing y. We substitute y by f of x or h of x or g of x or any letter of x equals mx plus b. So we substitute y by f of x, where we would have f of x equals mx plus b. That's the function notation of the equation of the line. Okay. Now, with this information, we can start with our first example here. They give me the the slope. Well, let's read this. They say write the point slope form of the equation that satisfies the given conditions. So the conditions are the slope of the line m equals -7/8. And the point is this. So they want the point slope form. So I'm going to come here using this. Slope is the slope of the line. M is -7/8. And then the y-intercept, well, not the y-intercept, actually. The point is -5, -9. So the point slope form would be y minus -9 equals -7, which is m over 8 times x minus -5. Well, obviously, I just replaced them. Some of you may have already seen that the minus times -9, but we never want to forget that if there's a negative number, the negative in the formula will multiply with that to change it into positive. So y plus 9 equals -7/8 times x plus 5 is the point slope form of the equation of the line. Now let's see what else they said. They said after you get write the point slope form, and then they say write the equation in slope in point slope form, and then here they say write it in slope intercept form. So we're gonna look for the slope intercept form here, but we do have the first one, which is y plus 9 equals -7/8 times x plus 5. Now, how do we find the slope intercept form after getting the point slope form? Well, we're gonna solve it for y, but put it in this format: y equals mx plus b. So we need to distribute the slope from the outside. Let me write this here: y plus 9 equals -7/8 times x plus 5. So I'm going to subtract 9 on both sides and then distribute the slope from the outside of the parentheses. So those two movements, those are the ones you do every time you have the point slope form, and then you want to transform it in slope intercept form. You need to distribute the slope inside and then subtract the value that is added to y to get y by itself. So y equals, that's -7/8x minus -7/8 times 5 minus 9. So, and then we simplify the equation. to get y equals negative 7, 8x. So over here, I'm gonna just perform this quickly. Negative 7 times 5 is negative 35 over 8 minus 9. So if we multiply top and bottom by 8 to get the common denominator, so that is negative 35 minus 72 over 8. So that is negative, that's negative, that's negative 107. So then that's negative 107 over 8, which is the point slope form, the slope intercept form. So that is y equals negative 7 over 8x minus 107 over 8. All right, that solves the first problem that we needed to solve. Next problem. Next problem here, and we need to pay a close attention to what they ask us to find here. They want us to first write the slope and the point slope form. Write the point slope form equation of the line perpendicular to the function. Okay, write the point slope form equation of the line that is perpendicular to the function below passes through 2, 5. So first, we have to remember that two lines are perpendicular. Two lines are perpendicular when their slopes the slopes are the opposite reciprocal of each other. The opposite well, now the question, when are two numbers negative reciprocal of each other? Let me give you some quick examples. Okay, so if I have, so I take A and opposite reciprocal of A. So if I take 1, say I take 2, the opposite reciprocal for 2 would be negative 1/2. 2 moves, flip the fraction, because when you take 2, it's 2 over 1. Then you take 2 as A. The opposite reciprocal of 2 is you flip that fraction and change the sign of it. So that gives you the opposite reciprocal. So if I have a line that has a slope 2, and then the perpendicular line to the line with the slope 2 will have a slope negative 1/2. What about if you have a line with a slope negative 3? What would be the slope of the perpendicular line, which means what is the opposite reciprocal of -3? You change the sign and you flip that fraction. So there's a 1 here. So that's going to be 1/3. This time, the sign is positive on the other side because the actual number was already negative, and you need to change the sign to get the opposite reciprocal. So the two words, opposite, reciprocal. Opposite is changing the sign. Reciprocal means flip the fraction. If you have a slope 2/3, if you have a slope 2/3, the opposite reciprocal will be -3/2. Flip the fraction and so on. If you have negative square root of 2 is a slope, the slope of the perpendicular line, which would have the opposite reciprocal slope of that, will be 1/√2, which is square root of 2/2. So that will be the slope of your perpendicular. So I wanted to make it clear for you to understand what it means when two lines are perpendicular. Now, since the line that I need to find its equation is perpendicular to the one that I have now, and the line passes through. So first, we need to know that the line is perpendicular to, it's perpendicular to this one that is -4, -4x -4x plus 9y minus 8 equals 0, and passes through the point 2,5. Now we need to find the slope of this line and its opposite reciprocal to get the slope of the line that we are solving for, right? So let's go ahead and write this in slope-intercept form to get the slope. So we're gonna solve this equation for y. So let's add 4 on both sides, 4x on both sides. Obviously we're gonna add 8 on both sides as well. So -4x and -8 on both sides. So the new equation will be -8. The new equation will be 9y equals, we need to add 4x on both sides, right? And then 8 on both sides. So that's 9y equals 4x plus 8. And then we will divide both sides by 9 to get y by itself. So we get y equals 4/9x plus 8/9. That is the equation of the line that is perpendicular to the line that we need its equation. So then we're going to use the slope of this line and its opposite reciprocal. Opposite reciprocal of this one would be what? Would be negative. So the slope I'm using here is -9/4, which is the slope of any line perpendicular to the one that was given to me. Now I have the slope and I have the point, I have the slope and I have the point, I can find the point slope form, which is y minus 5. 5 is y1, so that's x1, y1 equals negative 9 over 4 x minus 2. That is the point slope form. We have the point slope form here. That is y. That's y. And did they say, okay, so that's y minus minus, see here, y minus, where do I have it? It asked me to find the point slope form. So y minus 5 equals negative 9 over 4 x minus 2. So that is the point slope form. Let me put that point slope form. Next, they also want me to write this equation in slope-intercept form. Slope-intercept form, you know, you're going to want to use the point slope form to solve it for y to get the slope-intercept form. So I'm going to y minus 5 equals negative 9 over 4x minus 2. We will distribute that, right? And then add 5. So y equals negative 9 over 4, negative 9 over 4 x negative 9 over 4 x plus 9 over 2 plus 9 over 2 plus 5. So we're going to have y equals negative 9 over 4x plus 19 over 2. So that's the slope-intercept form. Slope-intercept form is y equals negative 9 over 4x plus 19 over 2. And then finally, they want us to write, let h be the function notation, function of x, and write the equation in function notation. So basically, the function notation will be replacing the y by h of x, since they already named the function as h in this equation. So I'm going to call it h of x equals, and then that's this, the same expression on the other side of the equation in a point slope form, slope-intercept form, will be the other side of the left side of the right side of your function notation. So negative 9 over 4x plus 9 plus 19 over 2. So that's the function notation. Let's go to our next example. In this example, they give me 2 points, negative 1, 1, and 8, negative 17. And they want me to write the point slope form of the equation of the line passes through the lines. And then they say, write the equation in slope-intercept form as well. So let's go ahead and do that. So since we know that having the 2 points, we can use the slope formula m equals y2 minus y1 over x2 minus x1, with x1 I can call this one x1 and that's y1, x2, y2, then come back to the formula to find the slope. We got to be careful with the negative signs in the formula because they're not only, they can distract you, mostly when you have one of the x1, x2, y1, y2 that is, it's also negative. So you want to make sure that you pay attention to all the distraction that can affect your answer. So x1, I mean, y2 is negative 17. So negative 17 minus, I bring my minus in the formula first, then I look for my y2, I mean y1. y1 is 1, so it's negative 1. Also, x2 is 8 minus in the formula, and x1 is negative 1. That turns this to a positive 1. So the slope m is negative 18 over 9, which is negative 2. So we have m equals negative 2. I have my slope. Now I can use one of these 2 points to give the point slope form, because the 2 points, both of them are points of the line. Because both of them are points of the line, I can just go ahead and use any of them. And I will always be smart when I'm choosing which one I'm using, because the bigger the numbers are, the more difficult it's going to be to perform your operations. So I'll take small numbers. So I'll take the first one, x1 and y1, to use to find the point slope form. So point slope form is y minus y1 was 1, so negative minus 1 equals slope is negative 2 times x minus negative 1, so plus 1. That's my point slope form. Point slope form is y minus 1 equals negative 2 times x plus 1. X plus 1. X plus 1. That's a point slope form. Not done, because we are told to find the slope-intercept form. We remember how to find the slope-intercept form is to solve for y. So slope-intercept form I'm going to subtract 1 on both, I add 1 on both sides, and then distribute this coefficient of, which was the slope of the line. So that is y equals negative 2x minus 2 plus 1. Y equals negative 2x minus 1. Y equals negative 2x minus 1 is the slope-intercept form. Moving on to the next example here. Now they're talking about lines that are perpendicular, parallel, lines that are parallel. Well, when are 2 lines parallel in terms of their slope? How is the slope of 2 lines that are parallel? Remember, 2 lines that are parallel are lines that will never intersect. Never intersect means that the slope of the 2 lines have the same slope. Same slope. So if I have the slope of one, it's automatically the slope of the other one. So I'm looking at this line. It's in slope-intercept form. The coefficient of x is the slope. So that will be also the slope of the line that I'm looking for. First, they say write the equation of the dashed line in slope-intercept form. Dash line. No, there's no dash line, right? Of the line. So, and then later on, when we get the slope-intercept, the point slope form, we're gonna write it in slope-intercept form, and then we will write it in function notation. We write it in function notation. So let's go, right? So slope M, because the two lines, the given line and the one that I am solving for, they have the same slope because they're parallel. So I'm going to call M3, which is the same as the one that was given to me. And then the point is what also is given to me, -6, -1. Now, let's go with the point slope form. Y minus plus 1, right? Minus 1 equals 3 x minus -6, so plus 6. So that's a point slope form. Easy and quick, because you have your slope, you have your point. There's not a lot of things that you need to do in order to find this answer. And then next, let's find the slope-intercept form, then write it in function notation. So we want to solve for y. Let's add 1, subtract 1 on both sides, and then distribute the 3. Y equals 3x plus 18 minus 1. So y equals 3x plus 17. But since they didn't ask me, they didn't give me which function, which letter to represent my function, I'm gonna represent it by f of x. So that's f of x equals 3x plus 17. So y slope-intercept form is y equals 3x plus 17. And in function notation, it is f of x equals, which could have been g of x or h of x, any letter of x, 3x plus 17. So that was it for the section 3. And next section will be about transformation of function.